Hi guys, it's a favorite teacher, Kamajimasa, and welcome to Skills and Academic Tuition Center. As Skills and Academic Tuition Center, we offer online tuitions and physical tuitions in mathematics, in physics, in chemistry, in biology, and integrated science. In this video, we are going to look at how we can calculate concentration. So basically, concentration can be expressed in two ways. There is what is known as the molar concentration. There is also what is known as the mass concentration. So we are going to break it down so that we understand fully what molar concentration is and what mass concentration is. So we are going to start with the molar concentration. So molar concentration, we are saying, is the number of moles of solute per unit volume of a solution. So what this simply means is that is the number of moles dissolved in 1 liter of a solution. So molar concentration is therefore calculated as concentration, which is equal to number of moles divided by volume. So the number of moles here is in moles, then volume is in cubic decimeters. So therefore, concentration or molar concentration is calculated in moles per cubic decimeters. Moles per cubic decimeters. Therefore, we can say 1 mole per cubic decimeters is equal to 1 molarity. 1 mole per cubic decimeters is equal to 1 molarity. So in short, we are saying molarity or molar concentration is equal to number of moles divided by volume. And the moles are in mole, then the volume is in cubic decimeters. Okay, example. So let's say a solution contains 60 grams of sodium hydroxide in 500 cubic centimeters. Calculate the concentration. Calculate the molar concentration. Calculate the molar concentration. So we write our data. So in this question, we have been given mass, which is 60 grams, and we have been given volume, which is 500 cubic centimeters. But we are told to calculate the molar concentration. So in order for us to calculate the molar concentration, we should convert this mass of sodium hydroxide into number of moles. So in order for us to convert the 60 grams of sodium hydroxide into number of moles, we are going to say number of moles, is equal to mass divided by molar mass. So our mass given is 60 grams. Then the molar mass, which is 40 grams per mole. This is the molar mass for sodium hydroxide, which is 40 grams per mole. So you cancel the grams, you cancel there, then you're going to have 1.5 moles. So these are the number of moles that are in 60 grams of sodium hydroxide. So we are going to use the number of moles. We are going to use the number of moles in order for us to calculate the molar concentration. So our data, we have molar, that is what we are calculating. Then number of moles, we have 1.5 moles. Then the volume, which is 500 cubic centimeters, but this one we convert it into cubic decimeters. We are going to have 0.5 cubic decimeters. So now we can use that information which we have to calculate the molar concentration. So we'll say concentration is equal to number of moles divided by volume. So our number of moles is 1.5 moles. Then volume, which is 0.5 cubic decimeters. Then when you divide these two, you're going to have 3 moles per cubic decimeters. Or if you don't want to write 3 moles per cubic decimeters, if you don't want to write the 3 moles per cubic decimeters, you can just say it's equal to 3 molar. So this is correct, even this part is also correct. It all depends on which one is workable for you. So you can either write it in 3 molar or you can leave it in 3 moles per cubic decimeters. So this is how you calculate concentration given in mass. Then you're also given the volume. First of all, you have to convert the mass given into number of moles. You know the number of moles that are there in the mass that is given. Then from there, you use the number of moles calculated to calculate the molar concentration. We look at now the mass concentration. Mass concentration. So mass concentration is the mass of solid, per unit volume of a solution. So in short, we're saying mass concentration is the amount of a solid dissolved in 1 liter of a solution. The amount of a solid dissolved in 1 liter of a solution. So therefore, we're saying mass concentration is therefore determined in grams per cubic decimeters. Grams per cubic decimeters. So this simply means that mass concentration is equal to mass of solid divided by volume of the solution divided by volume of solution. Okay, so now let's try to look at this example. So this example is saying calculate the concentration of a solution containing 20 grams of sodium hydroxide in 250 cubic centimeters of solution. 20 grams of sodium hydroxide in 250 cubic centimeters of solution. So What we are calculating here is mass concentration. We are not calculating molar concentration. Yes, it is very easy to calculate molar concentration just by looking at the information that we have, but what we are concentrating on is on how we can calculate the mass concentration given the mass and as well as the volume. So we write our data. So we have mass, which is 20 grams. Then we have volume, which is 250 cubic centimeters, but we convert it into decimeters. We are going to have 0.25 cubic decimeters. Then we are calculating concentration, which is the mass concentration. So now, mass concentration is equal to mass of solute divided by volume of solution. So mass concentration is equal to mass of solute divided by volume of solution. So this will be equal to, so our mass is 20 grams, then divided by the volume, which is 0.25 cubic decimeters. So when you divide 20 divided by 0.25 cubic decimeters, you're going to have 80 grams cubic decimeters. So our mass concentration is going to be 80 grams per cubic decimeters. I hope you followed through. Thank you for watching.